Hello friends, in this video we are going to discuss about the top 10 conceptual ideas for sequences for your preparation regarding mains examination, and this is the first conceptual idea from the sequences. The definitions and the very basic formulas from three different types of main sequences like arithmetic progression as well as geometric progression and as well as harmonic progression. See, arithmetic progression, a sequence in which the difference between the consecutive terms is a constant is an arithmetic progression. Here the constant difference is the common difference d, whereas here the ratio between the consecutive terms is a common constant, and that constant ratio is denoted by the r, known as common ratio. Arithmetic progression as well as geometric progression, common difference d and the common ratio r. Now when coming for the terms of the arithmetic progression, the terms of the arithmetic progression are like a plus d, a plus 2d, a plus 3d and so on. Every term is rising by d from the previous term, and here the terms of the geometric progression are ar square. By multiplying with r you will get the next term. Whereas coming for the terms of the harmonic progression, which are nothing but the reciprocals of these arithmetic progression terms. Harmonic progression is nothing but reciprocal for the arithmetic progression. See, if you observe this, you will say that nth term of the arithmetic progression is of the format a plus n minus 1 into d, and here the nth term is a r to the power of n minus 1. If you say 10th term is a r power 9, some 20th term is a r power 19, like that. Whereas the nth term of the harmonic progression is the reciprocal of the nth term of AP, and that is 1 by a plus n minus 1 into d. And from these nth terms we have an observation, very important observation it is. Usually you will get different questions regarding this observation in your previous competitive examinations, and the term is, see, T1 if you say the first term of the AP, Tn is the last term of the AP. So add the first term and the last term. Again add second term from the start and second term from the end. Again add third term from the start and third term from the end. Like that, if you add sum of the first term from the start and from the first term from the end, like that second term from the start and second term from the end, for this the summation is nothing but 2a plus n minus 1 into d in case of arithmetic progression. Whereas in the case of geometric progression, you just multiply this first term and that first term, this second term and that second term, the product is always equals to the ar to the power of n. We don't have any such observation in harmonic progression. And whereas coming for the sum of the n terms, if you add n terms of an AP, its rule is n by 2 times of 2a plus n minus 1 into d. Whereas in the case of geometric progression, sum of n terms is given by a into r to the power of n minus 1 by r minus 1. And if anybody asks you infinite terms, s infinity, for s infinity if you add infinite terms of AP, since AP is either always increasing or always decreasing depending upon the common difference. If it is increasing, sum of infinite terms is infinity. If it is decreasing, sum of infinite terms is minus infinity. So s infinity is directly plus or minus infinity, so we don't need any formula in that case. Whereas for the geometric progression, if the geometric sequence is increasing sequence, then the sum of n terms is infinity. But whereas if the geometric sequence is decreasing sequence, then we have a specific formula to find the sum of infinite terms, and that is a by 1 minus r. And when we will say that as a decreasing sequence means, we will say that sequence is decreasing if the common difference is less than 1, common ratio in the case of geometric progression, right? So sum of n terms is n by 2 times of 2a plus n minus 1 into d here, a into r power n minus 1 by r minus 1 in the case of geometric progression. Whereas s infinity we don't have any formula for AP, and for GP it is a by 1 minus r. If three terms a, b, c are in arithmetic progression, then the middle one b is mentioned as a plus c by 2 in AP, and that b is root of ac in GP, and that b is 2ac by a plus c in harmonic progression HP, when if three terms ABC are in the corresponding sequence. If three terms ABC are in the corresponding sequence like AP, then A minus B by B minus C. Have a look here. A minus B by B minus C is A by A for AP, and A minus B by B minus C is A by B for GP, and A minus B by B minus C is A by C for HP, harmonic progression. And when coming for solving problems, in certain problems we need to consider any three terms of AP, any three terms of GP, and any four terms for AP, or like any four terms for GP. In those cases, any three terms of AP are considered as A minus D, A plus D. And any four terms are considered as A minus 3D, A minus D, A plus D, and A plus 3D. We have to consider those terms to maintain a symmetry from both the sides, which will resolve our difficulty in solving the problems. For three terms, A minus D, A plus D maintains AP with common difference D. Four terms, A minus 3D, A minus D, A plus 3D maintains AP with common difference 2D. When coming for GP, three terms of A by R, AR, maintaining a GP with common ratio R. And any four terms, A by R cube, A by R, AR, and AR cube, maintaining a symmetry from both the sides, and where the common ratio is R square, and we will consider any four terms of GP like that. Right? So these are the very basic fundamental formulas regarding the three common sequences AP, GP, and HP, which are very helpful in solving the problems. This is the first conceptual idea from the sequences. Have a look here, then I will come with the second conceptual idea. Now, whereas coming for the second conceptual idea from sequences, this idea is completely about the arithmetic progression, different logics in arithmetic progression related to the JEE mains, right? See, for example, if you have the nth term of the arithmetic progression as 4n plus 3, and if anybody asks you what is the common difference, if the nth term is like 4n plus 3, then the common difference is directly 4, the coefficient of n. If the nth term is 3n square plus 2, then the common difference is not possible here. Why? Because see, the nth term of the arithmetic progression is given by the logic that n by 2 times of what is the nth term of the arithmetic progression? Nth term of the arithmetic progression is a plus n minus 1 into d. If you look here, this a plus n minus 1 into d is a linear expression in terms of n. Since it is linear in terms of n, nth coefficient is the common difference. It is not linear in terms of n. So this nth term, the sequence formed by this nth term is not an arithmetic progression. So we don't mention any common difference there. And sum of n terms, if it is an square plus bn, then the common difference of that arithmetic progression is 2a. And if the sum of n terms, Sn is like an square plus bn plus c, then arithmetic progression won't form here. So then there is no common difference. And after knowing the nth term, how to find Sn? By knowing nth term, to find Sn, we have a logic that n by 2 times of first term plus nth term will give us the sum of n terms. Sum of n terms from nth term. If Tn is known, just replace n with 1, you will get T1, and use that n by 2 times of T1 plus Tn to find Sn from Tn, and getting Tn from Sn. See, Tn is nothing but Sn minus Sn minus 1. Sn is what actually? Sum of the n terms. What is Sn minus 1? Sum of n minus 1 terms. From the first n terms, you just remove n minus 1 terms, so automatically you left with nth term. So Tn is Sn minus of Sn minus 1. Right? And another important thing is, if you know the ratio between the nth term and the see, two arithmetic progressions will involve here. Arithmetic progression 1 and the arithmetic progression 2. Nth term of this arithmetic progression is Tn, and here it is T dash n. Sum of n terms in this arithmetic progression is Sn, and in that arithmetic progression is S dash n. If it is given that the ratio between the nth terms of those two arithmetic progressions like an plus b by cn plus d, and they ask you to find the ratio between the sum of nth terms of those two arithmetic progressions. In that case, you just calculate that sum of nth terms of those two arithmetic progressions by replacing n with n plus 1 by 2, and that is nothing but a times of n plus 1 by 2 plus b divided by c times of n plus 1 by 2 plus d. Right? These two are the no if conditions. If you know this ratio, you will get that ratio, and from that you will get this one also. So these are the very basic, these are the very useful ideas regarding arithmetic progressions. And we have some more things. By knowing the nth terms, related to nth terms and the sum of n terms, we have some more ideas related to arithmetic progression which are frequently used in many cases. Among those, for suppose if mth term of the arithmetic progression is n and nth term of the arithmetic progression is m, then what you say about the kth term of the arithmetic progression? Mth term is n, nth term is m, then kth term of that arithmetic progression is nothing but m plus n minus k. If kth term is m plus n minus k, then what you say about the m plus nth term? Replace k with m plus n, you will get it as 0. So keep in mind that if mth term is n, mth term is m, and m plus nth term is 0. And another thing is, if mth term of the arithmetic progression is 1 by n and nth term is 1 by m, then what you say about the kth term? By knowing mth term as 1 by n, nth term as 1 by m, its kth term is given by the rule that mn by k. In that case, if anybody asks you to find, see, that is mn by k. So Tmn, if anybody asks you to find mnth term, see, replace k with mn and you will get it as 1. So mth term is 1 by a, nth term is 1 by m, then its mnth term is 1. In the same way, if you have that some m, Tm is equals to n Tn, that in the sense what? M times the mth term is equals to n times the nth term, then in that case also m plus nth term is 0. These are the different special arithmetic progressions. And in some arithmetic progression, if you say Sp is equals to Sq, sum of p terms is equals to sum of q terms of an arithmetic progression. In that case, if you try to find the sum of p plus q terms, then you get it as 0. Right? And another case is if Sp, sum of p terms of AP is q, sum of q terms of an AP is p, then in that case sum of p plus q terms, if you calculate, you get it as minus of p plus q. These are the very useful and frequently used special arithmetic progressions. So this is all about the second conceptual idea from arithmetic progressions, right? Then I will come with the third conceptual idea. Just have a look here. This third conceptual idea is regarding the sum of first n natural numbers, sum of the squares of the first n naturals, sum of the cubes of the first n naturals, like that. Sum of first n naturals is denoted by sigma n, sum of the squares by sigma n square, sum of the cubes by sigma n cube. See, sum of the squares is sigma n, the formula is n into n plus 1 by 2. And for the sum of the squares, sigma n square, which is n into n plus 1 into 2n plus 1 by 6. And sum of the cubes, sigma n cube, is given by the rule that n into n plus 1 by 2 square. See, by the number of terms in this sum, you just replace n, you will get the resultant value. Sigma n is nothing but 1 plus 2 plus and so on plus n. This is also notated like this: sigma I is equals to 1 to n I. And this is also notated like sigma is equals to 1 to n square, and it can be notated by sigma I running from 1 to n cube, like that. And for some of the fourth powers of n natural numbers, 1 power 4 plus 2 power 4 plus and so on plus n power 4, the rule is this one, the formula, that is n into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1 by 30. Sigma n square, sigma n cube, and sigma n power 4. And if you face anything about sigma 1, what you say about sigma 1? Sigma 1 means you need to add 1 for n times. By adding 1 for n times, you will get it as n. Sigma 1 is n. And for suppose if anybody say what is sigma 7, you need to add 7 for n times, then your answer is 7n, like that. And then sum of the first n even natural numbers is n into n plus 1. First n even natural numbers. If you add 2 even naturals, you just use 2 into 2 plus 1. What are the 2 even natural numbers? For example, if I say that 2 even natural numbers like 2 and 4. What is 2 and 4? 6 if you add. So replace n with 2, you will get 6. And the sum of first n odd numbers is n square. See, 1 plus 3, 2 odd numbers whose answer is 2 square. 1 plus 3 plus 5, 3 odd numbers and the result is 3 square. 1 plus 3 plus 5 plus 4, 7 odd number. 7, the answer is 4 square since we are adding 4 odd numbers. So sum of first n even naturals, first n odd naturals, first n naturals, sum of the squares of first n naturals, sum of the cubes of first n naturals. Using these basic formulas, we are able to solve many problems related to the sequences. For example, if anybody asks you, if anybody asks you to calculate a sequence like 1 into 2 square plus 2 into 3 square plus 3 into 4 square and so on plus n terms. If you have a sequence like this and we need to add, we need to calculate the sum of this. First of all, for the sequence you just calculate the nth term. What is the nth term? First term is 1, second term 2, third term 3, nth term n into 1 plus 1 square, 2 and the next term square, so n into n plus 1 square. Since this is n into n plus 1 square, if you multiply, you get that n into n square plus 2n plus 1. And if you multiply, you have that n cube plus 2n square plus n. This is Tn. Since Tn is n cube plus 2n square plus n, this is Tn. What represents? Nth term. For first term, replace n with 1. Second term, replace n with 2. Third term, replace n with 3. But what we need is Sn. So you need to apply sigma for this Tn. Sn is nothing but sigma Tn. If you apply sigma for this Tn, see sigma for this value. So which is nothing but sigma n cube plus, you need to apply sigma for 2n square, just keep 2 outside, 2 into sigma n square plus sigma n. And we have a formula for sigma n cube, a formula for sigma n square and formula for sigma n. Write everything in terms of n. After simplification, you will get that sum of the n terms of this sequence. So this is the way of calculating sum of n terms of for different types of sequences. See, for all these things, if you wish to calculate, first of all you need to identify the nth term of the given sequence. If you identify the nth term of the given sequence like an cube plus bn square plus cn plus d, then its sum of n terms is given by a into sigma n cube plus b into sigma n square, c into sigma n plus d into sigma 1. First of all, just identify, calculate the nth term, then apply sigma for that nth term, you will get the sum of n terms. So this is the way of calculating sum of n terms using sigma n square and sigma n cube. And there are some more sequences. See, if the nth term is like this. See, just observe it. I am going to tell you one more thing. If I have a sequence and I am calculating the nth term, the nth term will be like this, n into n plus 1. If the nth term is n into n plus 1, then just multiply, apply sigma, calculate Sn. And after calculating Sn, if you factorize it, you will get that nth term, sum of n terms is nothing but n into n plus 1 into n plus 2 by 3. And for example, if the nth term is n into n plus 1 into n plus 2, this is the nth term of the sequence, then the sum of n terms is nothing but n into n plus 1 into n plus 2 into n plus 3 by 4. This is the sum of n terms. Actual way is, after identifying nth term, multiply it, apply sigma, and then you will get Sn. If you factorize that Sn, you will get this format for these n terms. If you can extend this for any number of terms. If the nth term is n into n plus 1 into n plus 2 into n plus 3, then Sn is n into n plus 1, n plus 2, n plus 3, n plus 4 by 5. Like that, you can extend this rule for any number of nth terms which are similar to this one. Right? This is one important thing. And one more thing is, in arithmetic progressions, some of the reciprocals. For example, I have an arithmetic progression a1, a2, like that, an are in arithmetic progression. Then what you say about 1 by a1 into a2 plus 1 by a2 into a3 plus and so on plus 1 by an minus 1 into an. Just I consider 2 terms. For suppose if you take 3 terms, 1 by a1, a2, a3, 1 by a2, a3, a4, like that, 1 by, okay, what you say, an minus 2 into an minus 1 into an 3 terms. Or you may consider 4 terms also. As an example, I am considering the natural numbers like 1 by 1 into 2 into 3 into 4, 1 by 2 into 3 into 4 into 5, plus and so on, plus you may have up to n, right? So n minus 3, n minus 2, n minus 1 and n. Or for suppose you may say some numbers like 1 by 100, 99, 98 and 97. See, first of all these terms are in arithmetic progression. Since all these terms are in arithmetic progression, see, you need to calculate this one, 1 by a1, a2, 1 by a2, a3 and 1 by an minus 1, an. First of all, you just observe the difference between these two values. The difference is constant everywhere and the difference is b. So you just write 1 by d times of 1 by d times of this first part minus this last part. You just consider that one. 1 by a1 minus 1 by an is your answer. Whereas for this case, you just consider the difference between these terms. a1 and a3, the difference is 2d. a2 and a4, the difference is 2d. an minus 2an, the difference is 2d. And your answer is 1 by 2d times of the first part is this one. What is that? 1 by a1 a2 minus the last part is this one. 1 by an minus 1 into an. Just observe the pattern involved here and that pattern will solve many problems. Whereas if you observe this one, the difference between 1 and 4 is 3, 2 and 5 is 3, 97 and 100 is 3. So you just write 1 by 3 times of the first part. What is the first part here? 1 by 1 into 2 into 3. 1 by 1 into 2 into 3. Minus the last part. What is the last part here? This is the last part. 1 by 98 into 99 into 100. You will get the sum of n terms of the sequences of this format in this manner. Just observe here. So, this is the third conceptual idea from the sequences, completely about the special sequences of arithmetic progression. I already mentioned you in the previous topics and in the previous videos. You just utilize all these 10 conceptual ideas and these videos as a revision practice for your JEE mains examination. Thank you.